ask the question tomorrow about what a rational number is, you're all going to be able to tell me fraction, okay? So you're all going to get the answer correct tomorrow, okay? Fraction. Here we go. My fault on that. I need you to write this down, okay? Just to make sure we're all on the same page. Be sure you write that down, okay? Oops. Happy birthday to you. Happy birthday. Review. Just review this for me, please. If I wanted you to find the inverse of y equals 3x plus 7. Folks, talk to me. What would we do? Easy, switch x and y, right? Okay? So we would literally switch the x and y, and we would, bless you, we would bless you by solving how? By subtracting 7. And it would give us x minus 7 equals 3y, and then what would we do to both sides? Of course, we would divide by 3. And our inverse would be x minus 3 divided by 3, x minus 7 divided by 3. And we would use function notation just because it looks fancy. And you're probably going to see it that way. There are different ways to write it. What's another way we could write that? One-third x minus 7/3. That's the way I like to see it. If I had to graph it on paper, that's the way I would want it. Okay, I would want it broken down into a fraction x plus another number, because it shows me or tells me my y-intercept. It gives me my rise over run, my slope. So we're good, right? But do you see what we're ending up with? And it's good that I made a mistake at the beginning and I said, what's a rational number? Because look what we end up with. A fraction, okay? Yes. Because anytime we're finding the inverse of in function notation, the inverse is f to the negative 1 power. It means it's the inverse, yep. All right, so we know how to find the inverse. Folks, do you remember how to graph it, draw it in your calculators? Let's just do that. Mainly, I'm doing this for me because I'm the one that needs... Sorry. No. Cut my calculator on. Thank you. Here we go. We're going to put in our original equation, right? Okay, you do this yourselves. Our original equation is y equals 3x plus 7, y equals 3x plus 7, y equals 3x plus 7. We know that the inverse is going to reflect about what line? The y equals x. What's that called, folks? You got to know that. The parent graph. Yep. You got to know that. And then we're going to draw, correct? So let's draw. So second draw. And we're going to draw our what? Inverse. So it's option 8. And we're going to draw the inverse of vars, y vars, function y sub 1. And there's our original, and there's our inverse. And folks, look at that picture. If when I touch the smartboard, the calculator's going to go away. But if I were to draw the parent graph in there, It's going to be right here, right? Are both of those lines being reflected about the parent graph? Y equals X. Yeah, you can look at that and tell. Can you not? Be sure that you go back and do what with that inverse? Reset. How do you reset it? Clear it out. Clear it out. Second draw, clear draw. And I think it's gone away. Yeah, it's cleared out of there. Okay, so I'm going to clear out my equation. Just be familiar with how to draw the inverse, how to clear that out. You got to know how to do that. Here's another review problem. Why might I be giving you review problems? I'm guessing you might have a graded assignment at some point today, you think? F of x is going to be equal to 5x plus 4, and g of x is equal to 2x. That's what you're given. We're given an f function and a g function, okay? I want you to find f of g of x, and then I want you to find g of f of 3. Do that for me now, please. Just take a moment to do that. Here we go, f of g of x. That means that we're going to plug, I'll write my thoughts down, okay? I'm going to plug which function into which? G into f, correct? The g function into the f function. So if I need to do this with a different, because y'all know how I'm about my colors, okay? If I need to take my g function with a colored pencil, with a marker, with whatever, and I literally need to take that g function 2x and plug it into my f function, if that's all I need to write down, then that's all you should write down, okay? If that's what will help you. So we're going to write f of g of x, which is 5 times what now? 2x plus 4. Don't forget the plus 4 or the minus 1, because I tend to forget about it. Once I plug all that stuff in there, I go, oh, I forget. Now, simplify. 5 times 2x, of course, is 10x plus 4. Can I simplify that any farther? Am I done? How many of you got 10x plus 4? Rock on. High five. Boom. Let's go to the next one. Easy, easy, easy. What are we plugging into g of f of 3? What's that mean? What am I plugging where? I got to plug 3 into f first, right? This is a two-part problem. So I'm going to take f of 3. Folks, what's my f function? 5 times who? 3. Okay. That was loud. You're never that loud. That's all right. It's okay. 5 times 3 is 15. 15 plus 4 is, yeah, this video is going to be awesome. Oh, I'm done, right? Done. My answer's 19, right? No. What do I do with 19? I got to plug it into which function? The g function, okay? So now g of 19 is equal to 2 times who? 19, which is, how many of you had 38? Question, preguntas, fácil, difícil. I see. How many of you are I see with this? Comme si, comme ça. It's all right. It's all right. How do you spell that? All right. No questions at all. Moving on then. Here we go. This is from section 9.3, folks, and this is properties. Two things we're going to look at. We're going to look at the properties of reciprocals And we're going to look at the graphs of reciprocal functions and what we can do to those, okay? So calculators, calculators, calculators. Don't you ever come to this class without a calculator. You got to have it, okay? Here we go. If we had the function y is equal to x squared, what kind of function is that? Y equals x squared. What kind of function is that? What kind of picture would we get? A parabola. We would get a parabola. And that parabola would look like it would cross there at the origin. Do you agree? You guys agree with that? Yeah? I mean, how would we verify it? Come on. We would never draw that on paper. We would never set up an XY table. We would throw it in a calculator. I know that. What if, though, use your noggin, what if I looked at y equals x squared plus 3? What kind of picture would I have? I'd still have a parabola, but what would happen to that parabola, folks? It would move up 3. That's called a transformation, a slide up 3, right? So we had 1, 2, 3, and then our parabola would do something like that. Do you guys agree? Remember doing this? Okay? That's a transformation. Now, what is a reciprocal function? Everybody have that? Everybody good? Keep that parabola in mind of what we did to it. We moved it up 3, right? Or we can move it down 1. If I moved a parabola down 1, what would the function be? X squared minus 1, right? If it's just a basic parabola. Reciprocal function, folks, looks like this. F of x is equal to 1 over x. What can x not be? Y. Where x cannot be 0, somebody said it very quietly, because it'll be undefined. If x were 0, then it would be undefined, and that is not a good thing. Not good at all, right? If x were 0. Now, the graph of this, are we going to graph this on paper? Of course we're not. Why would we do that? Because you're going to take your calculator, and you're going to cut your calculator on. And you're going to put in that function 1 divided by x. I want you to look at it. All right, that's kind of strange, isn't it? That graph looks like this. And we've already looked at curves like this where they never cross what? The axis that only approaches it. We've talked about this. Folks, this is called that is not hyperbola. That's a hyperbola. Okay? It is not hyperbola. Don't call it that. Write it that way, but don't say it that way. It's a hyperbola. Now, let's think about this. What if we were to talk about domain and range again of this function? Domain has to do with which values? X values. What are all the possible X values? The width of this graph. Everything but what? 0. You know, we could write all this fancy notation, but it's all well and good as long as you know what that fancy notation means. How would I represent everything but 0? You do it this way. You could write all reals. What about the range? Think about the height. Range has to do with what values? Talk to me. Y values. So we're talking about the height of the graph, the height of the curve. What are all the possible Y values? All reals except for 0. Same thing. Do you guys agree with that? Even if you don't, trust me. Okay? It is. How about intercepts? Are there any intercepts? Are there x-intercepts? No. Are there any y-intercepts? No, doesn't look like it, does it? It's not crossing either of the two axes. So a hyperbola's got a whole bunch of stuff we can talk about, doesn't it? Now, what are we going to do with this reciprocal function? Turn the page. This is what we're going to do. My notes. Let's graph something different. You ready? Let's graph. F of x is equal to 3 over x. Calculator. All right. That was the original 1 over x, correct? Let's come in here and I'm just going to go right underneath what I already have in there. And 3 divided by x. And I'm going to go over to the left and I'm going to make that line heavy so I can see the difference in the two. You ready for this? Okay. What happened? It just kind of backed out away from the origin, didn't it? Okay. It kind of got broader. It kind of broadened out a little bit. Let me see that again. Get right there. So it kind of backed out. Y'all cool with that? Domain is still what? Still all reals. Range is still what? All reals except for what? 0. And then the range is also all reals still. What can 0 not be? I mean, ha ha ha. What can x not be? Thank you. And why can it not be 0, folks? Because it'll be undefined. The function would be undefined. We can't have that. Now, what are we going to do with this? Whole lot of material. Pay attention. If I lose you, you got to find some time. You got to look at the videos, okay? You got to look at the recordings. It's a big section with a lot of material. So hang in here. Ask questions when you need to. But I'm going to roll with it. Got it? All right, you ready? Let's look at one. If I were to ask you to determine the values of x for which f of x equals 2 over x squared plus 5x minus 24 is not defined. What are the values of x for which that function is not defined? What helps us determine whether these functions are defined or not? Say it again. The denominator equal to 0. We've got to make sure that we figure that out. So what we're going to do, folks, is we're going to take and figure out, we're going to factor it out, what values will make the denominator equals 0. Those are going to be the what will make it undefined. So we're going to take our denominator, and we're going to set it equal to 0, and that's denom and not demon. Okay? And we're going to take x squared plus 5x minus 24 is equal to 0. Cool with this? And then what'd you say, Anna? Factor it. Factor it if possible. Give me 2 factors of 24 that when I subtract, give me 5. 8 and 3. Signs are going to be different. Which one's going to be the plus? Plus 8 minus 3, right? And now, what am I going to do with each factor? Set it equal to 0. But x is going to equal what 2 values? -8 and +3, correct? So what's that mean? What does that mean? What are the 2 values that will make this function undefined? You're going to see it, you may see it like this on an SOL. It could be x is such that x cannot equal -8 or 3. You may see it on an SOL test like that. I'm okay with you writing x cannot, put the slash through the -8, put the slash through the 3, put a box around it. I'm okay with that, but I just want you to be aware that this is the way you could see it on an SOL test, okay? And let's look at this on the calculator. Now, of course, the calculator's off now. Yep. Thank you. You may just want to sit there. I don't know. Sorry. Clear everything out. Be mindful of parentheses here, folks. Let me pull this over here. All right, so here we go. 2 divided by, daggone. Parentheses, put your denominator in parentheses. Folks, it's okay for you to put x squared plus 5x minus 24. And I'm going to close the parentheses because y'all know how I am. Now let's look at this. Looks kind of weird, doesn't it? Real tiny. What's going on? What's going on here? Do y'all have that? Invalid? All right, if you got invalid, here's what I want you to do. Go second memory, second plus. Okay, hold up. Second memory, I want you to reset all RAM, number 1. Reset. And then we're going to clear everything out. And then we're going to do it again. Okay? So go back to y equals. Because we all, if you did that, we all should see the same thing. Let's, second plus. Here we go. 2 divided by x squared plus 5x minus 24. Great. What? Hit Zoom 6 for Zoom Standard. Are you on Zoom Standard? Still does it. It's because it's your birthday today. I don't know why. I really don't know why. Okay. Let's check one more thing. Go to second 0. To your catalog. Second 0.
Oh, okay. I didn't.
No. Just the number 0. All right, here we go. Go down here to D. I don't know if this has anything. I'm making this up. No. Cut diagnostic on and hit enter. And then hit enter again. Not that this is going to mean anything to our graph. Did you put parentheses around your denominator? Yes. All right, let's look at it again. You still don't have that graph. Okay, don't panic. Here's what I want you to think about. Which are the values that would make this function undefined? -8 and +3. It does show us that. Look right here. If you were to eyeball this graph, folks, what is going on? What's going on is this. If I wanted to graph this on paper, which we want to do, these lines that you're seeing, 2, 3, 4, 5, 6, 7, 8, I want you to put a dotted line at x equals -8. And we're also going to put a dotted vertical line at what? At x equals 3. And I want to look back at my graph for just a moment. Look what's going to happen. That's showing that this graph is doing something like this right here. Let me look at it again. Let me get this out of the way. Let me look at it again. And you can't see it. Hold up, hold up, hold up. Go here. That's what that graph is showing us. And you guys might can see it better with those blown up. If you were to zoom out, could you see it that way? But I want to show you something. Let's look at the table. Get that calculator, okay? The table has become my friend, and it will become your friend too. If you go second graph, now mine just appeared here. I don't know where your table is. But folks, if you look at x equals 3, what do you see? Error. Wonder why it's an error. What is going to happen if x is 3? The function's not defined, okay? Where should I also see another error? I should also see one at -8. Back it up and see. Oh, daggone. Look at there. Those are the values that will make the function undefined. Second table. This will become your friend. Write this down. Second table. Now, what in the world are these dotted lines? The dotted lines, folks, are vertical asymptotes. asymptotes. Giggle, giggle, ha, ha, ha. She said asymptote. I know you want to laugh. I can see it in your face. Vertical asymptote. I totally see it in your face. I know somebody. There's like, no, I'm not laughing at that. That's not funny. Everybody does. Everybody. All right, here we go. What is a vertical asymptote? Here we shoes throw you under the bus. At those places, a vertical asymptote is at those places where the function cannot be defined. Okay? The vertical asymptotes where the function can't be defined. And folks, there are vertical asymptotes and there are horizontal asymptotes. Okay? Now, how are we going to keep them separated? This is stupid, but When I was going over this, I'm thinking, oh my God, how am I going to get them to remember it? Here's how you're going to remember it. Gentlemen, you're going to remember this too. How do we find those values? We set the denominator equal to 0, right? Tell me what diva means to me. Virginia's at the end. Yes, Virginia's at the end. That's not what I was going for. I know myself, and I'm going to get it mixed up. But if I remember this stupid, I know it's stupid. I don't care. If it helps you remember, that's all that matters. What does diva mean to me? Y'all are still in the dark. Let me cut the lights on for you. Set your denominator equal to 0. Why can't y'all understand my mind? I know that's dumb, but if you'll just write, and I'm going to write it, I'm just telling you right now, I'm going to write diva on my paper every time. Nothing, it just makes the word diva. I got to have some way to remember, to think. I don't want to memorize this junk. I just need a connection. And if I think of diva, I'm going, denominator equals 0. Vertical asymptote, yes, diva. That's what that means. I know it's crazy, but it will help you remember it. You will remember diva, and you'll remember the word asymptote because it makes you laugh and smile and giggle and not pay attention. I'm looking at you. Diva. Okay, denominator equal to 0 will help you find the vertical asymptotes. Draw them, graph it on your calculator, draw the graph. Got it? How else are we going to use this? Here we go. Let's look at another one. If I wanted you to, here's the function, 6 over x squared minus 3x minus 28. That is messed up. Find the values that make the function undefined. Oh, once you do that, once you do that, then graph it. Okay? What are you going to do? Yep. You didn't see what? Guys, you work on this problem. Don't just sit there and wait on me to guide you like a bull, okay? With a ring through your nose. Yeah, you did. You got it. That's the same thing I had. Here's your 1. There's your second asymptote. There is no third. You got the dotted line on the left. You've got your y-axis, and then your dotted line on the right. We're going to solve, and we're going to set that denominator equal to who? 0. Factor it. 2 factors of 28, the one I subtract, give me 3. 7 and 4. Which one signs are going to be different? 7's minus plus 4. So that means x cannot equal 7 or -4. Now, without even putting it in my calculator, my vertical asymptotes are where? At -4 and 7. 1, 2, 3, 4. Bump, 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 bump. 1, 2, 3, 4, 5, 6, 7. Folks, we've got -4. We've got 7. And now's when I'm going to put it in the calculator. Because I'm going to put it in the calculator now to check it. Because you got to graph it. Oh, I know, but I don't care. So what was my function? 6 divided by. Got to use parentheses around your denominator. No, did it right.
So why is this one different?
Did I do that? It's the opposite. Subtract 8, which gives you minus 8. And add 7, which gives you positive 7. Opposite, right? Okay. Hey, do you have this? Are the graphs looking more similar now, yes or no? Does it look like this? No. But did we call the vertical asymptotes correctly? Is there a vertical asymptote at -4? 1, 2, 3, 4. If you eyeball it, you can check. How can I make sure it is? Table. Go to the table and make sure. -4, error. There better be an error at the wrong way. There better be another error where? Shoot. Yep, there it is. Right on. So now, let me go back to the graph. I've got to draw this. You're talking, I'm assuming you have this correct on your paper. Here. 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 Yes? Now, what could you tell me about this graph? We could talk about domain and range, couldn't we? Anything else I can talk about on this particular graph? Somebody said it. There's one other piece on this graph we can talk about. There's a y-intercept. Now, my sketch is probably not accurate, okay, because it's a sketch. But could I find the x-intercept using my calculator? Not the x. Y, could I find the y-intercept? Where do I find that? Second try. You're right, x needs to be 0, right, to find the y-intercept. So can't we just go second value? Because where x is 0, y is going to be what? Negative point blah, 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 blah. Where could I also find that value? In the table, okay? Go back to the table and check it and make sure. Do you have questions, yes or no? Nope, are we okay? Vertical asymptotes. Here we go. Let's look at another one. What example is this? 3? 4? Okay. All right, folks, identify. Identify the asymptotes. Domain and range of f of x equals 3 over x minus 2. Do that one yourself. Find all those things. Okay. Good. Ta-da! What's your range? All reals except for? And how could I double check it? Go to the table. Go to the table and check. Second graph. All right, 2, that's my y value, which is clearly my, or the asymptote. It's not mine. And then, What else does this tell me, my table? When x is 0, what happens? Thank you. The y-intercept, which is here, is at negative 1.5. Is that what it said? Yep. Okay. Just something else you can be able to find, something else you can pay attention to. Do you have questions on this? Yes. Because it approaches the x-axis, but it never crosses. And if you don't believe me, go to your table again and do this for like 30 minutes and see if it ever hits 0. It won't. Or do this for 30 minutes and see if it ever hits 0, and it won't. Okay? This is a hyperbola. If it's a 3-piece, it's still the same thing. Like this one. Pardon me? Yeah, still a hyperbola. No. Because of the asymptotes and this right here, it's just got the piece at the bottom. When you put it all together, I don't think so. The curve itself is a parabola, but we're looking at the big picture. We're not looking specifically at each. I'm looking at the big picture. Yeah. Pardon me? Yeah. We're actually classifying this as reciprocal functions. Rational functions, okay? That happen to look like that. Okay? All right? Here we go. Here's another. Oh, this one's different. Three, 4. Identify the asymptotes, domain and range of f of x is equal to 1 over x plus 2 plus 1. Folks, go straight to the calculator for this. Okay? Identify the asymptotes, domain, and range of f of x is equal to 1 over the quantity x plus 2 plus 1. Word to the wise, you better use what here? Use parentheses, okay? Separate that rational expression, that fraction, with its own set of parentheses. Look what I did. Okay, I completely separated that fraction with its own set of parentheses, and now I'm going to add 1. Okay? Yep. Look at it. Oh my goodness gracious. Yours looks better, right? Don't be a hater. I'm not hating on your graph. All right, look. Huh. Clearly on my beautiful graph that you guys are totally hating on, what is very clear? The vertical asymptotes where? -2, okay? I'm going to go ahead and draw that. -2, and I would also know that by diva, denominator equals 0, x plus 2 equals 0, x is equal to -2. That's the other way. So my dotted line, okay? Go back to that graph. But what else is going on here? It crosses the x-axis this time, doesn't it? Something else is going on. How far does this left piece over here go up to? What does it appear to? Or how could I determine by looking at what? Could I look at my table and try to figure it out? Look at your table, folks. Because something else is going on over here. And I got to figure it out. Second table. I've got my error at -2, right? But look at these numbers. Look at my y value specifically. What are they getting closer? Look what happens. As my graph, my curve goes to the left, it's getting closer and closer to what y value? 1. You know, we could do this for 30 minutes and it'd be the same thing. It's never going to get there. All right, go the other way. So 1's got something to do. 1 is significant to us. Okay, go back to your graph just to look. 1's going to mean something. Look at that. The larger, the bigger my x values get, what's my y value getting closer to? It's getting closer. It's dwindling down to 1, isn't it? So what do you think's going on with this particular graph? Not only is there a vertical asymptote, but now we have a horizontal asymptote. Now we've got 2 different things going on, okay? So we're going to draw our horizontal asymptote at 1. And I'm going to put it here 1, and this was -2. Because I want it labeled. I mean, if you're going to do it right. And now I forget what my graph looks like. All right, so now this is going to cross here. Bad. Let me do this again. And up here. There's one other, well, there are 2 more values that I could make very precise on my graphs if I wanted to be very particular. The intercepts. And you guys know how to find those, okay? Do you guys agree with that? All right. Pardon me? The x-intercept. What's another word for x-intercept? X-intercept is a 0. So let's find the 0. I mean, while we've got the calculator, second trace 0, and I want to go to the left. It'll hop, my spider will eventually hop over there. There it is. But I want it to the left. I want it to the right. So my 0 is at, oh, look at there. Need to go play the lottery. Went through it. It is at -3, and then my y-intercept, how do I find my y-intercept? Value. I need my x value to be what? 0. Look what y'all taught me on this calculator. That's 1. That's 2, because clearly my graph is perfectly drawn. Never is. Huh? Ah, that's another way. Good job. To go in through the back door and figure this stuff out. The table is very, very valuable to you. Okay? But this one, how about domain and range? Just here for our notes. Domain, folks, what's the domain going to be? The x values. Everything but what? -2. So we would put all reals except -2. And how about our range values, folks? All reals except +1. Very good. What do you think? Questions? How did I get positive 1? That's when I went to my table. I noticed in my graph that it had been shifted, okay? We slid that graph up, and that's when I went straight to my table, and I started looking and trying to figure out what it was getting close to, what my Y values were getting close to, okay? And I did that using my second table. Yes? Okay. There are conditions that we're going to go. What are we doing right now? We're looking at the graph, trying to figure this stuff out using our graphing calculator, right? There is a way to calculate where the horizontal asymptotes will occur. Okay? So we have to think about that. Look at this one real quickly. The function 2 over x minus 4 minus 3. And of course, I want you to find the asymptotes graph and then name the domain and range. Do that for me. Do that on your own. If we look at the big picture, this function has how many pieces? 2, right? And don't I have a linear type function in the denominator, x minus 4? You guys notice that? Look at this one. What's going to happen when you get a binomial? Nope, that's a lie. When you get a trinomial in the denominator, how many pieces are you going to have? Look at this. We're going to look at this real quick. Algebraically, I can find my vertical asymptotes, right? That's why I write this, so I know it's vertical. Give me 2 factors of 14 that when I subtract, give me 5, y'all. 7 and 2. That means my vertical asymptotes are what? At 7 and what? -2. Everybody with me, yes or no? My horizontal asymptote, folks, I'll find it in just a moment. But put this in the calculator. 3 divided by how many pieces do you think is going to be part of this graph? Look at example 1 in your notes. If there are 2 pieces, 2 curves in example 5, how many pieces to this graph do you think there will be? There will be 3, okay? Let's verify that. So we're putting 3 divided by x squared minus 5x minus 14 and we're going to graph it. Looks like there are how many pieces here? 3 pieces, okay? So let's draw it real quickly. Vertical asymptotes at -2, 2, 3, 4, 5, 6, 7. -2, +7. Hey, what about my horizontal? My horizontal asymptote? It's getting closer and closer to 0, isn't it? Isn't it getting closer and closer to the x-axis? And what do you notice? Folks, this is when you learn, you really figure it out. There is something to be said about discovery. And we don't have time because of this stupid vowel SOL. I hope that's recorded. I hate the SOLs. But there is a lot to be said about discovering what's going to happen. Okay? What do you think? Why is the horizontal asymptote 0 for this one? And of course, my graph isn't very good because it should be closer to the x-axis. There was something added on, wasn't there? That value was added on. Keep that in mind. Okay? 2 pieces, plain old linear function in the denominator. 3 pieces, trinomial in the denominator. Something to think about, something to ponder upon, okay? Yes, sir. Say, well, my x-axis for this problem is my horizontal asymptote. And if you need to write that down, for this problem is my x-axis. And it's very clear on the graph. Yes, sir. So what now? Right here or the problem before? Problem before, pretty much that last piece happened to be our what? Not our slope. Our y, our what? A horizontal asymptote. Now, here's what we're going to do. Time out because the bell's going to ring. Here's what we're going to do for tomorrow. There's still, algebraically, I need to show you how to be able to find the horizontal asymptotes. Okay? I'm going to have that printed out for you so we don't have to spin our wheels writing all this mess down. Okay? I'll have that copied for you. What do you have due for me tomorrow? That little slip of paper. All right, for homework tonight. And I think on that little slip of paper it's very clear that it's due when? It's due tomorrow. No excuses. Okay? Unless, you know, now if you have something major, I'm not even going to speak anything bad. But if something were to come up that's really bad, then you need to tell me. You need to let me know instead of going, she said I'm not going to accept it. All right? But if it's just because you got a case of the lazies, size 10, we'll want to go up your asymptote. Graded assignment. It's on the little piece of paper, okay? It's an asymptote. Secondly, workbook. Due tomorrow. Workbook page. Look at page 119 in your workbooks. And folks, let me see this real quickly. I'll probably type this in so I can look at my workbook. Page 119. I love this workbook. Oh, psh. Folks, look at numbers 4 and the first number 9 on that page. Actually, yeah, if you look at that page, you'll see there's a typo. Actually, go to page 120. That'll be even better. Forget 119. On page 120, look at number 1. Oh, dang it. At number 1, and go back to page 119 and look at the first number 9. Yep, that's all. Have a good day. Get my work done.